So we now have this concept of dimension at our disposal. And dimension is very, very useful concept. And really, to me, maybe the most important takeaway from the whole lecture is summed up in this image. So this is the same image we introduced when we talked about bases, but now we can add a little bit to the image. In particular, what we have now are the dimensions of all four of the fundamental subspaces. Remember, the dimension of the column space is always the same as the dimension of the row space, and that number is equal to the rank. The dimension of the null space is the nullity of the matrix, and the dimension of the left null space is the nullity of the transpose. Now, these numbers are quite easy to compute with the computer. The rank is the number of pivots in the reduced row echelon form, the nullity is the number of non-pivot columns, and then the nullity of the transpose is the number of non-pivot columns after we transpose. So what I have here is the same code from the previous lecture, which is the same code that produces bases for all of the fundamental subspaces. But now, after each one of those basis calculations, it tells us the dimension of the space. So I'm just going to click Evaluate, and let's interpret the results here. So the matrix that I've predefined is this 2 by 4 matrix. And here I have the reduced row echelon form of the matrix and the reduced row echelon form of the transpose. If we look at the column space, we're getting 2 bases. And remember, our first theorem from this lesson says that any 2 bases for the same space has the same number of vectors. So we shouldn't be surprised that our 2 bases have 2 vectors in them each. So this is telling us that the dimension of the column space is 2. And that's the rank of the matrix, as we see from the reduced row echelon form calculation. What about the row space? Here we get 2 bases for the row space. And the thing I'm interested in now is the fact that they both have 2 vectors in them. Again, that's the rank, and that's the dimension of the row space. What about the null space? We know that the dimension of the null space is the nullity. So we have one basis here, that has 2 vectors in it. And if we go to the reduced row echelon form, we see that we have 2 non-pivot columns, which means that we get 2 vectors in the basis, which means the dimension is 2. And finally, for the left null space, which is the null space of the transpose, well, think about what the equation is that defines that space. It's A transpose V equals 0. And when we look at the reduced row echelon form of A transpose, we see that there will be no free variables. So we know that the only solution to A transpose V equals 0 is the 0 vector, which means that we don't have a basis here. All we have is the 0 vector in this space. And what we said from the lesson is that in this situation, we just say that the dimension of the space is 0. So this is a nice tool to sort of summarize a lot of the important information about a given matrix. We have all 4 fundamental subspaces, and we have bases for each of them, and then now we know that the dimension is just the number of basis vectors.